We'll be doing a very practical course with you in the next couple of days where there's lots of hands-on exercises, and then hopefully plenty of time to actually work with you on your own codes on applications of interest to you. As Ramon said, I'm Brian Wylie, and my colleague Felix Schmitt here is at the front. He'll be also sharing a lot of the work with us today. I'm from Jülich in Germany, which is close to Aachen, for those of you who are not aware of it. And Felix is from Dresden, which is on the other side, in the eastern part of Germany. So we have a very loose outline for the course over the 2 days. We typically start on the first day with some introductory material and then go through the basics of doing some profiling, getting some very high-level, broad information about the execution of your parallel applications using tools like Scorpio and Cube. You don't need to know these right now. Those will be introduced to you in the course of today. And then hopefully the time after we've gone through some introductory exercise with you to actually start using these tools with your own code. After we've done a profiling part of the workshop, then we would move on to do some tracing to get some more detailed information about the interaction of our processes and threads. And that'll be introducing tools called Scholastica and Vampire. Maybe it'll be tomorrow, maybe we'll actually start with some of that in this afternoon session. But we want to make sure there's plenty of time for you to try out and use the tools with your own codes, because that's what you're most interested in. And we'll fit in presentations and additional exercises as appropriate. You should be familiar with the PizDaint system. I just put a basic information onto the slides here. We're more interested in the software environments that are available because that's the part that the tools interact with most closely. We're here to help you. Felix will help, Jean-Guillaume will help. There's probably a bunch of other people from CSCS who can come in and help us. Feel free to raise your hand, ask questions, or shout and ask questions so that we can address things if you're having problems. For the VI-HPS, Virtual Institute High Productivity Supercomputing, this is the framework in which we have prepared our training exercises. It was something that was set up 10 years ago now in 2006 by the Helmholtz Association in Germany, which was at the time keen to facilitate interaction between different groups, especially in this area where we were trying to work with the group in Dresden, groups in Jülich, other parts in Germany, to work together to improve the quality of the tools that we have, to improve the quality of the training that we have, and to help application developers get the most productive experience from the highly parallel systems that were available. There's a range of tools provided by the different partners. We're going to go through not all of them with you in the course of this workshop, but we'll focus on a few of them. We're going to be using something that's one of the NAS parallel benchmarks that's configured for MPI and OpenMP. You don't need to know what this benchmark is doing. It's coming from NASA. It's from the NAS parallel benchmark suite. It's solving Navier-Stokes equation in 3 dimensions. It's not a particularly great example in terms of showing performance problems because it's a benchmark that builds and runs on a lot of different systems, and it runs relatively efficiently. There are things that could be improved that can certainly be adjusted in different ways, but it's just a convenient example for us that we can build and run, and we've used for different systems. We've used it in Blue Gene systems, Cray, K-Computer in Japan, Fujitsu systems, a whole range, and it's, for our purposes, it's a good. I hope that you're ready to copy the course exercise tarball, which is in the course account, to your own Scratch directory. So this is where it's appropriate to set up the environment. Before we build and compile things, we need to make sure that we have the appropriate compilers configured and the appropriate runtime libraries. So when you're doing performance analysis, it's usually a good idea to be using relatively new, if not the newest versions of the MPI and other libraries, because there'll be bug fixes, there'll be performance improvements. So there's additional things that are available that are not necessarily in the default versions. But if the tools were built with a newer version, so here we're using version 7 of the MPI library, those won't work with older versions of the MPI library. So if the default library is MPI 6, then it won't work with the newer versions of the tools. So that's why we're encouraging you. If you do a make in this directory, this base directory, it will just outline the options which are available, how you can select which benchmark to run, different classes of benchmarks, or different sizes of computational problems. So it will run through using your default environment and using the appropriate, or using, in this case, the OpenMP flag. And you need to uncomment the line which is appropriate for your programming environment, because the Fortran compiler is the same for each environment. It will then go through, it will compile the different sources with OpenMP enabled, and it will build an executable. That executable will be given the name btmz_c, which is the class that's configured, and .8, which is the number of processes configured. If you have specified things yourself, in principle you could specify a different class or a different number of processes. This is the configuration that we have the batch script set up for, which we recommend using for this exercise. So let's get it running. CD into the bin directory. We provided some job scripts that you can use as a basis. So just copy this job script from the job script directory. There's a subdirectory for the Daint system where there's a number of scripts provided, and we'll just use the basic ones for running it.